Hello, precalculus class. Today you're going to learn all about the ellipse. But to start, I would like you to do this warm-up. You can pause the video here and give it a try. Okay, here is your answer. First thing I did was complete the square. Oh wait, before I even did that, I recognized that it was a parabola, and that's because it has a y squared term, but not an x squared term. I also know that it's a horizontal parabola. See down here, it fails the vertical line test because it's not a function, it's a y squared parabola. So then I had to complete the square. First I factored out the 2, and that makes the negative 32 be a negative 16, and negative 16 divided by 2 is negative 8. Negative 8 squared is 64. What I really added to this side was 128. So you can see I added 128 over here. And then I moved the x and the 119 over to the left. When you complete the square, you get 2 parentheses y minus 8 squared, and you have negative x plus 9. You want to pull out the coefficient of the x term from both so you can find your x coordinate of your vertex. Did that here. Then I divided by the 2. So it turns out we have y minus 8 quantity squared equals negative 1/2 parentheses x minus 9, which means our vertex is at x coordinate of 9, y coordinate of 8. Our p-value, if 4p equals negative 1/2, that means p is negative 1/8. So that means the focus point is 1/8 from the vertex, so that's 8 7/8, 8. So plot it a little bit to the left here. The directrix is 1/8 in the other direction, so it is at x equals 9 1/8. And then I can draw in the parabola by finding the latus rectum by doing 4p, which is negative 1/2. So I go up a fourth and down a fourth, and that gives me my pretty narrow parabola. The other thing is I have an axis of symmetry at y equals 8. So that's the reflection of the parabola. Great warm-up problem, good example of what you might see on an assessment. Okay, so today we're going to talk about the ellipse, which is right here. And we can have a horizontal ellipse. So an ellipse is like an elongated circle. So a horizontal ellipse will look like this, and a vertical ellipse will look like this. It's just its alignment in the coordinate plane. Once again, you don't have the xy term, you just have those. An xy term will cause that ellipse to be rotated, not horizontally or vertically, and we will talk about that later. But an ellipse has both an x squared and a y squared term, but in a circle, those coefficients are equal and the same sign, and both exist. In ellipse, those coefficients can be different values, or must be different values, so you could argue that a circle is a subset of an ellipse, but they must also be the same sign. So they're not equal. Their product is greater than 0 because if it's a negative and a negative, it's going to be greater than 0. If it's a positive and positive, it's going to be greater than 0. And you can see the two equation forms. We'll talk more about those in a minute. Okay, here's your definition of an ellipse. An ellipse is the collection of all points in the plane, the sum of whose distances from two fixed points, called the foci, is a constant. So is a fixed number. In the parabola, we had a focus point as well, but here in the ellipse, and also you'll find out in the hyperbola, we have 2 focus points. So you can see the plot here. This picture is of a horizontal ellipse, and it'll just help us identify a few things. We have the center of the ellipse here, and then we have the major axis, which has the vertices and the focus points on it, and that's the, it's a horizontal axis if it's a horizontal ellipse, and for the vertical ellipse, it's going to be a vertical major axis. And then the other axis is called the minor axis. So there's some values we label A, B, and C in this equation, and they're going to go, or in this graph, and they're going to go into our equation. The key, though, is any point on the ellipse. So if I put a point here, the distance from the focus here and the focus here, if you add those two lengths together, is a constant value, and that constant value will be 2 times the A value. So likewise, if I put the point here and I look at this length plus this length, it's the same as the other two lengths added together. All right, now I've made the picture quite messy. Let's continue talking about it. So if an ellipse with center at the origin and major axis coinciding with a coordinate axis is shifted horizontally h and vertically k units, the resulting ellipse is centered at hk. So we're going to be able to have a center of an ellipse in our equation when we go to that standard form. And the equation will look like this. So let's keep everything on the screen so you can see the graph as well as the standard form of the ellipse. But what you see here is the h coordinate of the vertex, or of the center, goes with the x, and the k coordinate of the center goes with the y. And when it's horizontal or vertical, the equation looks very much the same. They're always equal to 1, and they're divided by this a squared value and this b squared value. So the only thing that changes between these two is which one is under the x and which one's under the y. So in a horizontal major axis ellipse, the a value, which is the distance from the center to the vertex, is under the x term. And in the vertical major axis ellipse, the a value is under the y term because of the alignment of the ellipse. And then the b value, and b is the length from the center to the point on the ellipse along the minor axis. So you can see in the picture up here, b is that distance. The key in an ellipse is the a value will always be greater than the b value. If a was equal to b, you would have a circle. So we're not talking about circles here, and there's definitely a difference. So there's one other key point, and that's the relationship between the a and the b, as well as the c value. So the c value up here, if you can see right here, the c value is the distance from the center to the focus point, which defines the shape of the ellipse. So you can have ellipses that are long and skinny, or ones that are shorter and wider. But there is a relationship between these three values, and that is right here. It says that c squared equals a squared minus b squared. So I just always remember that a squared is the largest value, so that means c squared is the subtraction of the a squared minus b squared. These look really familiar, if you will, because these three terms go into a Pythagorean theorem equation. So let's just solve this, and then you might be able to see it on the graph better. If I make it a squared equals b squared plus c squared, it says there's a right triangle between these three. So if I move it up here, and you look at a squared and b squared, so if you put in red here this length, a squared, this is the same length here that this is. It may not look perfect in our drawing, but this is a right triangle here, and b squared plus c squared equals a squared. And that might be a way to remember that little relationship. There's going to be a similar relationship with the hyperbola, but it will be different. So you do need to find a way to remember it. And then once again, c is the distance from the center to the foci, and very important, a is greater than b. We're going to do some with the examples on the next couple slides. All right, so here's an example where you're given some key facts about an ellipse and you're asked to write the equation. In order to do this example, I am going to graph it because I think it'll help us see all the key values that we need. So the first thing I'm going to do is draw a little coordinate plane here. And I'm going to plot the center. It's 2 over and 3 down. And I'm going to label it a C for center. And then the focus, 1 is at 3, -3, so it's just 1 away. I'm just going to put a little X there. Call it the focus. And 1 is at Oh, and one vertex is at 5, -3. So there's the vertex. We'll make a little x there, but call it the vertex. So based upon that, I know that this is a horizontal ellipse because the vertex and the focus are on a horizontal line with the center. So that means that is your major axis. I also know that my A value, which is the distance from the center to the vertex, is 3. And my C value, which is the distance from the center to the focus, is 1. So if I know A and C, I also know B. So I'm just going to change my pen here. So we know that A squared equals B squared plus C squared. So 9 equals B squared plus 1. So B squared is 8. And that means B is 2 root 2, which is approximately 2.83, which I'm going to go ahead and plot on my graph. So if I go from C in the other direction, 2.83, and down not quite 3 here. And then we know there's symmetry in both directions on an ellipse. So I'm going to plot the focus to the left and the vertex to the left. 1, 2, 3. And actually draw my ellipse here. So boy, it looks very circular. And if you think about it, A is 3 and B is almost 3. So it is very close to a circle. But we have everything we need now in order to write our equation. So let's go ahead and do this. Since it's horizontal, I'm going to start with the x squared term. So you're going to have x minus the x coordinate of the vertex squared. And we'll add that to, it's always a plus here, the y term. And that is minus the y coordinate of the vertex, so that's a plus 3. The equation always equals 1. And since it's horizontal, I put the a squared underneath the x term, and I put the b squared underneath the y term. And that is your equation of this ellipse. All right, with our next example, we're given the equation of an ellipse in general form, and we have to complete the square to turn it into standard form, and then graph and identify key information about the conic section. I'm going to go ahead and complete the square on it, and then we can talk about graphing. So as you can see, I grouped my x terms and my y terms, and I completed the square twice. And I added 81 to the right here, and then 16, because it's 9 times 9 and 1 times 16. But right here is where I wanted to talk about it a little bit. An ellipse equation has to equal 1. So right now it equals 144. So what I'm going to do is divide both sides by 144. And that indeed is forcing it to be equal to 1. And by doing that, I'll end up with the values for A and B, or A squared and B squared, by finding 9 goes into 144 16 times, and 116 goes into 144 9 times. So this worked out very well. And now I have the equation of an ellipse. Notice 16 is greater than 9. So that means A squared is 16 and B squared is 9. So A is 4 and B is 3. That means it's a horizontally aligned ellipse because the 16 or larger value is under the x term. My center is at -3, 1. And now we can graph it, and we'll identify also where the foci points and the vertices are. So I am going to draw a little coordinate plane here. Okay, I'm going to plot my center. And I'm going to go ahead and make some points for the vertex. We know that the center to the vertex is 4 away horizontally in each direction. So I'm going to put a little x here. Put a little x here. And we know that the other, or what they call the co-vertices, are the B direction from the center and the vertical direction. So I'm going to go up 3 and down 1, 2, 3. And I can draw a picture of my ellipse. Now, I do want to also identify these ordered pairs. Sometimes you write them down. So the vertices are at 1, 1, and what is that? -3 plus 4, -7, 1. The co-vertices are the minor axis vertices, so those are at -3 up 4 and -3 down -2, 3 away from the center. And I also need to find my C value. So the C value is from the center to the foci points. So remember, it's a squared equals b squared plus c squared. So it means 16 equals 9 plus c squared. C squared equals 7. C is the square root of 7, which is approximately 2.65. So I can plot it. If I go just about 2.5 over and 2.5 over in this direction, there's my focus points. And I can identify that those locations. So the way I'm going to write that is I'm going to take my center point, so foci, at -3 plus or minus my C value, because it's right or left those, and they're both up 1. And there's where your focus points are. And you could also write the vertices or co-vertices that same way if you had a radical or something. All right, this is our last example for the ellipse. This time I'm giving you a graph, and you need to write the equation from the graph. So first of all, you see that it is an ellipse. You see that it is vertically aligned. So I'm just going to write down the equation of the vertical ellipse because we haven't dealt with one yet. That's going to be y minus k squared over a squared plus x minus h squared over b squared equals 1. So I can write the equation if I can identify the center at hk and your a and b values, which you can see from this is fairly straightforward. So first of all, we know the center is at -1, 3. Note, the y is always with the y coordinate of the center, and the x is always with the x coordinate of the center. The ellipse is always a plus sign. And then my a value is the center to the vertex, so we can see that a is 5. And my b value is the center to the co-vertex, so that's 3. So now let's write our equation. Y minus 3 squared plus x plus 1 squared equals 1, and these are divided by 25, don't forget to square them, and 9. The last question says, where are the foci points? Well, we need to find the C value. So a squared equals b squared plus c squared. A squared is 25, b squared is 9, so that means c squared equals 16, and c is 4. So that means your foci points, we'll label them right here, are on the major axis, 4 away from the center. So center, foci, foci. And I can write down those ordered pairs. They're at -1, and one is up, let's see, 7, and the other one is at -1 and down -1. And there is your locations. That is it for ellipses.